Good afternoon. Thank you so much for joining us for our lunchtime Steam Bites workshops. My name is Jason Mazarek. I am a project specialist at the San Diego County Office of Education, supporting the STEAM Hub this year, of which the STEAMpower Conference is a part of. I am very excited to bring you this really short, concise, but interesting and engaging activity while you are simultaneously scarfing down your lunch before you either head out to the next session or get back to the students. Just a real quick heads up, our sessions this week for the STEAM Bites workshops are all pre-recorded, and they are pre-recorded because they often show an activity or a demonstration that if it goes wrong the first time, there's not a whole lot of time in that 15-minute window to correct the error. So for your convenience, these are pre-recorded sessions, and that just means that you will be able to watch this session over again at a later time if you'd like by going onto the STEAMpower website, or rather onto the STEAMpower schedule. But also, while the session is ongoing, I'm able to answer questions that you have in the chat room because I'm not also occupied with running the actual demonstration. So I'm going to get that started in just a moment. I put essentially a summary of what I just said in the chat room. Real quick shout out for those of you who are signing out, maybe right on the dot. Please do visit the eval form. Those evaluation forms are really valuable for us so that we know what is working and what is not working. So without further ado, give me just a moment and I will cue up our session today, which is on kitchen chemistry. How can we do chemistry at home in the kitchen with materials that we can either gather that we already have, or by doing a really quick shopping visit to a grocery store and picking up the materials. Kitchen chemistry coming to you in just a moment. Hi, I'm Jason, and welcome to our STEAM Bites workshop, where we present 10 to 15-minute workshops on an activity or a resource that you can use immediately with your students right after the workshop is over. And today we're going to be focusing on kitchen chemistry. We're going to use a pH indicator to test common things around the home. So things that you find in your refrigerator or underneath the kitchen cabinet are all fair game for today's workshop. Now, to use our pH indicator, we are going to purchase red cabbage from the grocery store. And we are going to prepare this, and this will become our natural pH indicator. You can purchase a pH indicator. When you do that, though, you're purchasing a chemical, and with that comes the added complexities of storing that chemical and taking the precautions that come with handling chemicals with your students. Now, if you use a natural pH indicator, it's just a little bit more accessible. Maybe it's a little bit more, a little less expensive, and hopefully a whole lot more accessible to you and ultimately to your students. So I'm going to take you through the steps of preparing our pH indicator, and then we're going to do some basic steps. So to get started, we're going to take our cabbage, and we're going to slice the cabbage into strips. You have two different ways that you can prepare your pH indicator. You can boil your cabbage, meaning you can cut it into strips, put it in a pot with water, and boil it for, let's say, a half an hour. But when you boil cabbage, you also spread that cabbage smell around the area that you are cooking in. And not everyone is fond of the smell of boiled cabbage. So if you want to avoid that smell, if you don't want your home to smell like boiled cabbage, the alternative is to blend the cabbage. Now, I have my cabbage sliced. I don't need the entire head of cabbage. I can just use maybe a quarter of it, use the rest for food later on. And what I'm going to do next is I'm going to take my strips of cabbage and I'm going to combine it with water in a blender. Now, ideally, you would use distilled water. If we are testing the pH of household items, we want to start off with a neutral solution here. And unfortunately, not everyone has access to distilled water, or you just may not have it on hand. You can use tap water. Just know, though, that with the impurities in our tap water, you are not starting with a neutral pH indicator. That's okay, because it'll only be slightly off from neutral by a few decimal points when you're measuring the pH. Not a deal breaker when you're doing household chemistry, but of course, if you were to do this in a lab or if this was a more serious experiment, you would definitely want to use distilled water. For our purpose, though, tap water is going to work just fine. Okay, so let's get blending. I have my blender here, and we're going to combine our cabbage into the blender with, in my case, tap water. And I want to use a decent amount because this is what I'm going to use to mix in with what I find around my home. So I want to add, let's say maybe a cup or a cup and a half of water. Precise measurements, not so necessary. Just know that you need enough water to get everything blended and so that you can extract that, what will become a purple juice from our cabbage. Perfect. So now you have your pH indicator, but of course you have all the clumps of the cabbage in there. So get yourself a strainer. I have a mesh strainer, but if you want to use a cheesecloth, or even if you just have a paper towel, put it over a spaghetti strainer and let the juice drip through. You'll lose a little bit the absorption of the paper towel. Again, that's all right. This will still work if all you have is a paper towel at your disposal. So go ahead and strain out the pulp of your cabbage. Again, the longer you blend it, the more of this will get pulverized. But for our purpose today, I did a quick blend to show you what our end result is. Now, a neutral pH when we're using red cabbage is going to be what you can see here is kind of like a purplish color or a very, very dark blue and purplish color. This is what we're going to consider to be neutral, meaning if we were looking at a pH scale, which is on a scale of 0 to 14, this would be at 7. It would be right in the middle. And again, it would be neutral. It wouldn't be acidic and it wouldn't be basic. We're going to make sure that we preserve some of this neutral solution so that we can reference it when we mix in other solutions. All right, so what do we have? What did I find in my refrigerator? What did I find in my kitchen that I am going to test? Well, you may have a pool or a hot tub where chemicals need to be added periodically to maintain the pool. And one of the things that's tested in a pool is the pH level. So you may already be aware of testing and maintaining a certain pH in things like a pool or a hot tub. In this case, though, we're going to use our pH indicator to test the acidity or the basic properties of our household ingredients. So let's get started with our very first one, which is going to be vinegar. Now, you can ask your students to describe what vinegar is like. Where do you use it? Well, you would use it in cooking, and you would use it when you are possibly cleaning. It has served some purpose. If you put it in a spray bottle and use it, it does a good job of cleaning surfaces. In this case, though, we want to figure out, is it acidic or is it basic? Now, we're not quite sure at this moment what color is going to indicate an acidic solution or basic solution. So we're going to start slow by simply combining some of our pH indicator in with the vinegar. And look, you can see a color change immediately. Our neutral pH, which is a dark purple, changed to a reddish color when we mixed in the vinegar. So let's put our vinegar off to the side for a moment, and let's choose next, let's choose bleach. And for this, I'm going to put on my safety glasses just in case we get some splash from our bottle here. Take every precaution that you possibly can when you are working with these chemicals. Vinegar is again a safe one that you'll find in your kitchen, but bleach, on the other hand, make sure that this is done with parental supervision or adult supervision if you are encouraging your students to do this at home. So I'm going to mix in some of our pH solution, our pH indicator rather, and we didn't get a red like we did with the vinegar. Instead, there's a yellowish color, almost a tinge of green in there, which may or may not get picked up on our camera there, but it's a yellow green, a very clear yellow green. So let's put that over onto the other side of our table, because these are very different colors. Okay, what do we have next? I have two more things to test. I have baking soda. And baking soda, of course, is going to require a little bit of a stir since it's a solid. This is the one solid that I am testing. And let's see what happens here. I'm going to mix in our pH indicator, and I'll have to give it a stir. Ooh, we're getting something very, very different here than in the prior two tests. All right, so that color is a dark blue color. Now, I'm not quite sure where this falls on the spectrum, but I'm going to place it off to the side so that I don't knock it over, but I'm going to place it over onto the bleach side, since blue and green, I know, are sometimes a part of the same family, more so than maybe red when we're looking at the color spectrum. But I'm not quite sure if these are correct just yet. We're going to have to revisit the order. I have one more. I have lemon juice. I'm going to add some lemon juice to our final cup, and I'm going to test this and see what we get. Add some of our pH indicator here. And interestingly enough, our lemon juice takes on a very similar color as vinegar. And that's interesting. I wonder what's similar about lemon juice and vinegar. Why are these two showing us the same colors or similar colors? So again, if I line up our cups here, we have baking soda, we have bleach, we have lemon juice, and we have vinegar. Now, what is this telling us? Well, in order to figure out what is acidic and what is basic, we need to do some prior research. We need to find out, when we use red cabbage as our indicator, which colors correspond to which numbers on the pH scale. Like I said earlier, the pH scale goes from 0 to 14, with 7 being neutral. I know that purple, or a very, very dark purple, is neutral. I know that that's in the middle, because, well, I only mixed in tap water with that cabbage juice. So I know that our purple will be somewhere in the middle. And now if I go in opposite directions, I'll get reds when I go over to the acidic side. So lemon juice and vinegar are acids. As we go over to the basic side, we get bleach and baking soda. So we get blues and greens, and in this case, a very clear color, and almost a tinge of green in there. So we have our bases on one side, we have our acids on the other. Now I have one more thing to test, and I have no idea what to expect here, because again, the purpose is to rummage through your bathroom cabinets, your kitchen cabinets, find things that you can test. I have some shampoo, and I want to see what I will get when I mix in some shampoo into a cup, and then I add some of our pH indicator. I have no idea if this is going to fall on the acidic side or the basic side. See if I can get that mixed in there. One thing I definitely don't want to do is I don't want to use a spoon from the baking soda. I don't want to cross-contaminate. So I should have brought a second spoon. I don't have that with me, so I'm just going to give it a stir. But we can see here that this purple is lighter. It's more violet in color, less dark, less intense than our pH indicator. So although the shampoo didn't fully dissolve, we can see that it's a lighter purple color, almost like maybe more of a maroon color than our pH indicator. So we would then ask our students, well, where would we place this on our scale? If we've established that reds are on one side and blues and greens are on the other, is this closer to a base, or is this closer to an acid? Where would it fall on the spectrum? And of course, by the time you're done, and by the time the students are done, they may have a whole lineup of cups. And if they sort the cups and the colors that they see from the pH indicator properly, they can identify approximately what the pH level is of that particular substance. So using red cabbage as your indicator, you can store this in a refrigerator for several weeks in a sealed container, of course, making sure that that cabbage smell doesn't get out. This over and over again until your pH indicator is done. And then again, if you need more, it's as simple as cutting up, chopping up, and blending additional red cabbage. So what else can you test? What more can you find around your home? Well, I encourage you to look around at cleaning solutions and things that you find in the shower or in the bathroom, things that you find in your refrigerator door that are like lemon juice or vinegar, and test those out and see what you get. The end result here is that students should be familiar with the difference between acids and bases. One takeaway that you may have made a connection with already is that our bases tend to be used in cleaning solutions. So for example, baking soda is something that you might find in a detergent. Bleach, of course, is a cleaning solution. Versus acids, those tend to be more enjoyable for us to eat. Now, never mind the shampoo. Let's go ahead and put that off to the side. But lemon juice and vinegar, those are things that we cook with and that we season our food with. So we can start drawing conclusions once we line up all of our cups. We can start to categorize these items based on how we use them. And then we can start to see relationships between how we use these items and the pH level or the color that they've indicated in the cup. So there are a number of possibilities. The only thing holding you back is your imagination. So find some things to test, mix some pH indicator with red cabbage, and explore all of the really, really cool things that there is to learn right in your own kitchen or right in your own bathroom. I hope you enjoyed. Thanks a lot, and we'll see you next time. All right, folks, just as a closing comment, as you make your own pH indicator at home, in this case with red cabbage, your pH indicator will be a dark purple. If you purchase a pH indicator, it will come in a variety of different colors. So phenol red, for instance, is red. Bromothymol blue is blue. And because they arrive at a neutral level in a variety of different colors, when you mix them with acids and bases, they will turn different colors. So what you need to do is you need to figure out what the color scale is for your specific pH indicator. For red cabbage, acids turned red and bases turned dark blue, green, and almost clear in the extreme case of bleach. If you were to get bromothymol blue, the color changes would be very different, meaning acids would not necessarily be red. They would be a different color. So you have to look up what that color scale is for your particular pH indicator. That's what I meant by you need to do a little bit of research. As long as you know that, you can identify pH levels, but it's less about identifying specific pHs and more about establishing patterns, finding ways to organize the different cups and the different substances that you are testing. So it's not necessarily about saying, oh, vinegar is a 4 on the pH scale. That doesn't necessarily do anyone any good. But being able to group and compare and contrast the different things that you test, that's the real takeaway. That's the powerful thing that you want to get from your students. And if they're moving in that direction, the actual number, meaning the actual pH number, is really is just sort of background information at that point. I will hang out for a little bit if anyone has any questions on how to implement or any next steps or any questions that you may have about what to do and how to implement this. If you have a moment, please, please, please go ahead and click on this form. Go ahead and send some feedback our way now that you've attended our 15-minute session. And of course, we will be repeating this with a different theme throughout the week. So Tuesday through Friday, we'll have different topics. Check the schedule if you want to know what those topics are. And I look forward to seeing you tomorrow. Enjoy the rest of the conference.